Yeah, what I want to talk about today is common pitfalls I saw when I did code reviews on test code of our apps. I work at Adesso Mobile. It's a company based in Dortmund, Munich, and Münster. We do all kind of mobile development. We do web development, app development for all bigger platforms, and cross-platform development, native development, all that kind of stuff. And we're writing tests. Just brief history of our travel with tests. Prior to 2012, we didn't write tests. That had to do with all kinds of reasons. Mainly, the test frameworks prior to 2012 sucked. This was prior Roboelectric 2. That was when robotic tests were really slow. And so in the early days of 2013, we started writing tests. The frameworks have evolved, and I thought, great, we will reach great code coverage in no time. But the reality proved me wrong, and we stick with coverage around 5 or 6%. That was our biggest coverage in some project, but the coverage was still pretty low. And then in 2015, I said, yes, we reached a great coverage, about 90%. The unit tests were running, the automation tests were running, and I thought everything was fine. But again, code coverage is not equal to test quality, because coverage just means somebody had called this method to a test. It doesn't mean he had tested this method. It was just called. And then the code coverage went up without any test. Just call the method, code coverage went up, everything great. But I don't want to talk more about meme generator and start with some test code. And the first one I saw was sticking too much to assertions on return values, especially from people who write tests for the first time. And that has something to do with the Hello World tutorials for writing tests. For example, that's the first Google result for Java unit test example, and then you find something like that. Some kind of calculator, and then you give in two numbers and asserting the value. In this case, you multiply with 0, so the result should be 0. The hello world of JUnit. The problem is, all hello world examples show more or less helper classes. Some kind like string util or a calculator or something like that, not real logic code. And all time, I didn't see a hello world JUnit example with, for example, mocks. That all on assertions of on return values and something like that. So in an extreme example, we had a test. Void just called the backend, and when the developer went in and write the test, he said, I can't assert a void return value. So he just added a return true at the end, and then said, yes, assert true. So everything worked. It's some kind of extreme example. Didn't happen a second time for any developer I have ever met. But that was true in 2013 for nearly all our projects. We had more or less coverage in the controllers or activities and database, and very poor coverage in views, but 100% coverage in the util package. Because then again, string util, add two strings, and assert the strings are concatenated, or calculate examples. Util classes are easy to test, but very unimportant for a project. Another one I saw very often, I just have one example for this part, tests that can be fooled easily. Because, so they're still green, except the whole code is broken. To explain that, just met the requirements of the sample code. We have a call to our backend system, and it works without an auth token, it works with an auth token, but when the auth token is set, it has to be appended to every call to the backend. That has to be implemented. And the developer implemented it. So you can see he used retrofit. And here we have our init client. It takes a token. It's an interceptor, and the token is added to every request. And then the client is created, and that's the whole code. A bit obfuscated, but that's very productive code. And that's the test of the code. He creates a spy with Mockito on the client factory, gives in the auth token, and then he verifies that the init client with the auth token parameter is called one time, and that the client is not now. Who can tell me what's wrong with this code? Sorry? Right. Right. Let's do a little bit of refactoring of our code and just delete everything inside init client. And then we just initialize the empty client. And the test code will still remain green. And the reason for this mistake is he's testing the implementation details. So he wrote the test after he wrote the source code, and then he knew what he did and said, yes, when this method is called, everything is fine. But he totally lost the requirements he wanted to test and just test what he had implemented. So let's have a look at the refactored test method. And then, oh, I see there's a copy-paste error. This spy is useless, just ignore it. It's just new client factory with the auth token. Then he registered empty response in Roboelectric, and then he just called the backend system and asserted that the authentication token is appended to the last sent HTTP request URL. And then again, now the test tests the requirement to append something to the URL and not the implementation detail to call the method which appends something to the URL. And that is something that happens very, very often when the test code is written after the real implementation code. Let's get back to our implementation. Another thing we see is that the client and the init client method are protected. And they actually mean to be private, but to make an assertion, the verifier in the mock, they had to be protected so he can assert that it's called. So that again, he just changed the implementation to write the test on the implementation details. That's also wrong. And that brings me to the next part, testing private methods and making them protected, therefore. That's again something which happens when the logic is written before the test. Because when you think of, just forget everything about clean code and write a public method which does something. That it's very, very long, some if, some else, and a big fat spaghetti code. And then you write a test for that. Everything's green, everything is fine. And then you do the refactoring. You put some part in a private method, another part in another private method, and the test is sufficient. It's still working, and it still tests what the public method promises to do to anyone who uses this API. And it's completely uninteresting if there are 1, 10, or 100 private methods, because the contract is alone in the public method. But when you do the refactoring before the testing, then you think, yeah, that's it, that private method, and I have to call it, and so you write a test calling that private method. And again, thinking of coverage, the private method is called during testing the public test, so the coverage doesn't went up if I test a private method separate. And again, it's just testing the implementation details, not the real test logic. And there are two reasons why you don't need it. On the one hand, every private method has to be called by a public method, which has to be tested. Or the private method is not called by any public method, and then it's that code and can be deleted. So there's no reason for writing tests for a private method and making it protected. Know your tools. Mostly when I talk with two developers about Roboelectric, they know that part. They know, yeah, the test runner, the config annotation, and we can create activities with Roboelectric. And then, for example, I saw many lines of code and hacking with Mockito to create mocks inside the Android container, just because the developer didn't know that Roboelectric already provides mocking. For example, in the shadow resolvers for content resolver, I just can register a mock of a content resolver with my authority through the shadow content resolver in Roboelectric. And there are many other methods in the content resolver to inject test code or mocks, which are not so good documented in the Roboelectric documentation. I think that's very common again. Roboelectric can mock HTTP requests if they use the Apache client and not the Apache Connect, because Roboelectric can intercept only the Apache client. Next pitfall. It's only test code. That's the beginning of all evil. It's just the test, not the production code. The production code is nice and clean and it's separate and it's the architecture as well, but the test code is spaghetti code again. Just giant functions and methods who do everything again and again and again. So write clean codes also for tests. You have to change tests often as you change the implementation. Maybe not as often, but very similar. And even your test code has to follow suitable patterns. You have to think about how to write your test code, how to create components for tests, how to create packages for tests, and something like that. And otherwise, the efforts to keep your tests running will increase, and then you will abandon the tests, and it will be dead code in your project. And one very important thing is you have to separate automation and instrumentation code from the test code, because that's two part of things. And as you know, for clean code, every class should do one thing, not instrumentation and testing, but instrumentation, the one class, and testing another class. I have one example for that based on Appium. In this example, we are testing a web view inside a native app. And what we want to do is we select a target, a destination in a booking process, and then look again if the selection is present in another input field. Some simple example. And that's the test code. We get some random targets, our test data, and then we just called select targets. That's the instrumentation. And then we look if our target value is inside the input field. And that's the instrumentation code. We select target, we click the select target button, then we click every target we want to select, and then we click confirm, and then we have select a target. So we have one class for the test and one page object. That's a common pattern in when writing Selenium tests, a page object, which encapsulates everything you can do on this particular view. And for that case, we can select target in every test we like without rewriting all the instrumentation, the clicking and the selecting again. So that's a very, very common and nice pattern to separate instrumentation from the real testing code. So, and now to the last, and in my opinion, most important case for testing, static coupling. You can't test code which is which is coupled static. Therefore, follow the inversion of control pattern that can be dependency injection like Dagger, but it hasn't to be inversion of control. The most important part is don't initialize classes you need inside the class, but outside the class, and give them in as parameters. And therefore, avoid singletons, the plain Java singletons, not the Dagger indentation singleton, but the plain Java singletons, get instance, and something like that. Avoid static methods. That's very strange because of the big utility package, but avoid static methods because you can't test really good static methods. You can use PowerMock, but that's only a tool for bad designed code. And in every case, static code must not be stateful. Avoid global states. That's a real problem because you can't reset a global state in every test. That only leads to some strange methods like reset or set for testing or something like that in your singletons or static or global states. But that's again code you just write in your productive code to test it. And that shouldn't be done. And have in mind that Android itself provides some inversion of control mechanisms like registering services in the manifest, registering content provider in the manifest, all that is inversion of control. So you set the implementation in another part, then you use it. So you can inject mocks through a separate manifest, for example. Yeah. Here a quick example. This part is completely untestable because we can't inject any mock or something like that when we just call the static get instance and then do something. Where would you inject or replace that implementation through a mock? On the other hand, if you just give it as a parameter, for example, or with an it inject or something like that, then you can inject some mocking example or some stub, and then you can do all the testing inside the unit test. Okay. And I'm through. Well.